Let's take a look at the slope of a line. While the inclination of a line seemed like a simple representation, a relationship between the inclination of a line and the coordinates of points on it cannot be found without resorting to tables of trigonometric functions. Thus, we consider the slope of a line another expression related to inclination. So the slope m, denoted by m, of a line is a tangent of the inclination. So in other words, m, which is the slope, is equal to tangent theta. And take note that in trigonometry, we know that tangent theta is equal to y over x. So let's consider this figure. If you notice here, we have a point P, xy, and if you drop a point parallel to the y-axis, you will be able to form a right triangle. So tangent in a right triangle, theta is equal to y, the length of this side of the formed right triangle, over x, the length of this side. That's why we have tangent theta is equal to y over x. And this will help us understand the slope of a line. Now, for the slope of a non-vertical line that passes through the origin P with the coordinate xy is m is equal to the change in y over change in x. Since we are talking about a non-vertical line, so we have here negative y over negative x, which will give you y over x, which is your tangent theta. However, sometimes lines are not conveniently placed. So let's try to consider this. We have P or point 1 with the coordinates x sub 1, y sub 1, and point 2 with the coordinates x sub 2, y sub 2. So let's take a look at this one. So we have the given 2 points here, P1 and P2, and we can connect this to form a line. And we will be able to find for the slope of this line. Now going back, we know that the slope is equal to tangent theta or y over x. So if we drop a line from P2 parallel to the y-axis, we will be able to form a right triangle here containing the 2 points P1 and P2. Since the slope is y over x, so this is side y, this is side x. But we do not know the measure of side y and side x. But we have the coordinates. So if we plot this, or if we take the point on the intersection of this line and a line passing through P1 parallel to the y-axis, this one, we will have a point Q here, and this point will have a coordinate which is equal to x sub 2, y sub 1. The intersection, x sub 2, because this is x sub 2, that's the x coordinate is x sub 2, then you get the y coordinate of P1, which is y sub 1, so we will have a point here Q, which is at point x sub 2, y sub 1. Okay. So if we are going to find for the measure or the distance between these 2 points, you will have x sub 2 minus x sub 1. That will be your x. For y, you will have y sub 2 minus y sub 1. That will be your y here. This one, slope m, y over x, which will now give us the formula for the slope, which is the change in y over the change in x, or y sub 2 minus y sub 1, x sub 2 minus x sub 1. Okay, so we can define that now. A line through P1 located at x1, y1, and P2 located at x2, y2, where x sub 1 and x sub 2 is not equal, has a slope which is equal to the change in y over change in x, or y sub 2 minus y sub 1, x sub 2 minus x sub 1. Okay, sometimes they call this rise over run. It says here, the slope is positive when the run is upward to the right, and the slope is negative when the run is upward to the left. So let's try to take this example. Find the slope of the line containing the points p sub 1, 1, 5, and p sub 2 at 7, negative 7. So if you're going to graph, sometimes it is easier to visualize if you are going to plot the points. And then you connect them to form a line. But this one should be easy. Okay? So this is how I do it when I was in high school. I label these points. So for example, for P1, I label 1 with x sub 1, 5 with y sub 1, 7 with x sub 2, negative 7 with y sub 2. Okay? So that you can immediately use the formula by just replacing the numbers here from the points given. So you have y sub 2, our y sub 2 is negative 7, so you have negative 7, minus y sub 1, y sub 1 is 5, so minus 5, over x sub 2, our x sub 2 here is 7, minus x sub 1 is 1, so 7, minus 1. So you will have negative 12 over 6, or your slope now is negative 2. You notice that we have a negative 2 slope, so you know that the line drops from left to right. Okay? Or it rises from right to left. If you can immediately tell by looking at the sketch of the graph that the slope is negative because it rises from right going to the left. So I hope that's clear for the slope of a line.